LGVs. So there is practical no limits for the application of the servo motors. Some clients are adapting the machines that they have to change from normal AC motors to servo motors because they are much faster, the position is very precise, and so on. Something is happening here that I don't understand. I hope you can follow this. So each motor has an encoder on the back of the motor. This is the feedback that he gives to the drive, so that the drive can know exactly where the motor stays, where is the position, the real position of the motor. Some motors have incremental encoders. They are also precise, but they can't save the position where they are if you should off the power supply. So the most of the servo motors are using absolute encoders. If the encoder is an absolute encoder, an optical absolute encoder, you can turn the axis of the motor and it won't lose the position, even if the power is cut it off. For absolute encoders, the magnetic and absolute encoders, you can't turn more than one turn because it is magnetic and it doesn't know exactly where it is. So if you turn it less than one turn, then yes, he knows where it is. But if you turn it more than one turn, it is the possibility that you lose the position. This is the development on the timeline from WECON of the developing of servo motors. The project started about 2016 and increased with models up to 2024, 2025. We have now the VD2L and VD5L. This is very economical servo drives. I don't know if you can see my image. I have here one unit. This is a very simple one. We will talk about this later on and talk about the specifications of this servo drive. Okay, it's very small. It's light, and there is a good dissipation in it. As you can see, this is a very perfect combination of performances here. But we will talk a little bit about this later on. Those are the models that we have at the moment. We have the economic type, and then he goes up to the VD5L, also economic type, but this one with EtherCAT. The VD2, the standard type on the middle, has a larger interface connector because this is the model that has everything on it. You will see it later on. It is the most advanced one. The economical ones, they have a small interface connector, but there are less possibilities to interconnect the drive by his I/O port. This is the VD2F. The VD2F goes up to 1.2 kilowatts, maximum 4 Newton meter. And it can also have encoder type of 17 bits or 23 bits absolute encoders. And they are supplied with the 220 volts, one phase. This is the appearance of it. You can see, well, you can't see because the interface RS 422 and 485, it's on the top. Okay, it's on the top. You can see it here, but I show it to you on the picture. It is here, so you can interface this with a PC or a PLC. As you can see, this very simple one. We have the interface on the CN2 and the encoder communication on CN1, and then we have the power supply and the output for the motor below. The operation panel is very simple. It has soft silicon buttons. It is very easy to use and access to the parameters. This servo drive, the VD2L, has also dynamic braking integrated with E-gear ratio range and encoder output feedback. The gear E-gear ratio, it's an electronic gear that we can adjust the real resolution, mechanical resolution, to the impulses that we give. If you want to set up, for example, 100 pulses for millimeter, you can make this E-gear ratio in order to achieve this. So it will be very faster and easier to use on the PLC and our programs on the PLC. This is also the VD2L. This is a low-cost one also. It goes up to 1.2 kilowatts. And then we have the same, more or less the same connection. But this one has the USB interface. This is a USB type C for the connection to the PC. So it is faster and easier to program. Okay. You don't need any converter to have the RS485. It goes directly by USB. This is very, very good. Now we have the VD2. This one, it's the strongest one. It goes up to 7.5 kilowatts, 48 Newton meter. It can go with motors with up to 4,000 RPM. Most of them have only 3,000. And we can use a power supply 220 volts or three-phase 220 or 380. At the time as you order the drive, you have to choose the right one. Okay, if you want to use it 380 volts AC, you have to choose the right reference. This is the types of shell. Let me explain you. This is the same model, the VD2, but we have up to 14 amps, the size or type A. This is the smallest one. And when we go up to with the power, it will be larger, and the type C is also a little bit taller. In this one, we have the connections for the servo motor and the power supply. It's connections, connectors here. You can see it. And the middle one has this dark plastic cover that covers screws where we connect the individual lines to screws. And the type C is also in this way. And as you can see, the CN2, the connection for the interface, is also very large because this drive has everything on it. Inputs, outputs, including the output simulation of an encoder. For some applications, it is very important to have this because this gives you the feedback of the real position of the servo motor. So, for example, some CNC machines, they give the signal to the drive, but they need the feedback to know if the position is right or wrong. This is very important also. This is the only one that can do this, the VD2, okay? Here you can see all the connectors of this drive. Unfortunately, this drive doesn't have the USB-C type to program, so you have to use the RS485 interface to get access to the drive. But it is very easy to do this. This is the larger one, the B type, and here you can have on the larger one you have already RS485 connector. You don't need to use the interface to communicate with it. This is the largest one. It's taller, and you have the RS422 connector for the communication. Okay, the interface communication is also the largest one because it has all the IOs available. So mostly the most different that we have between the VD2F that has a lower price and the VD2 is that it has a analog input. So the VD2F doesn't have analog inputs, and the VD2 has it. They have two analog inputs. They can use, for example, to choose a velocity or a torque. And they have encoder pulse output. This I have told you before. The others don't have this, but the rest is very similar. Then we have the newest ones. They have EtherCAT. EtherCAT is a protocol that is used more and more in the industry. It avoids a lot of cables and connections because we can make everything through EtherCAT. Our LX6 series or the AC60 series PLCs, they have integrated already the EtherCAT communication, so we can use a cable connected directly to the EtherCAT and control the equipment with the PLC without any kind of connections. The most application stays with the CN2, the connection for the IOs, completely open, not use it, okay? So you can see what the people are looking mostly. They are looking for short lead time, delay, high reliability, and high speed response. And with EtherCAT, the VD3E, you can move several axes, 8, 16, 32, 24, 64, and so on, with the same line and very, very fast. Therefore, higher requirements are put forward for the interconnection of the equipment. It is very easy to make the installation, the physical installation on the machines. Here we have an example, an LX6 series PLC. And this is a multi-axis motion control. We have only 3 here, but we can have 4, 8. Then you have to be aware also to order the right PLC because these PLCs that can have motion control, they have a special reference on it because the lowest price, they don't make any motion control. Then it goes up to eight axis, 16 axis, 32 axis, 64 axis, and so on. So you have to be careful. You have to choose careful the right reference of the PLC to use with EtherCAT. Okay. This processor that is inside the EtherCAT drives, it's a tiny beast, as I used to call it. It is a Texas Instruments microprocessor. It's a dual core, and it is so fast and so powerful that on this image you can see what in the past was happening to make, for example, the interpolation of a round shape. If you see on the right side, you can synchronize the two axes to make this interpolation with much more points. So the shape will look very, very rounder or much rounder than the image of the left side. This new series of drives have a very powerful potentiality of making this kind of interpolation. And as the VD2, this VD3 has also these three shapes and goes also for up to 50 amps. This is the main aspect of these drives. The connectors are similar to the other ones. Here you can have the USB Type-C to connect the servo drive to the PC and make the parameterizations. And the EtherCAT communications is on the top. So you have two connectors, one to receive the information from the PLC, and the second one to go to the next node, to the next drive or whatever. This is the larger one, the same connectors in there, and this is the most powerful one. Okay, it's a little bit taller, but the functions are the same. Now we have also the VD5L. This is very, very new. This is also a new drive that you can order. It's already available. It goes only up to 1.3 kilowatts, 5 Newton. It has also a 70-bit or 23-bit resolution encoder, and it is powered by 220 volts AC. You can see that this drive has also the USB Type-C interface to make the communication. Sorry?
It's okay. It's okay.
Okay, so if you have any questions, you can write them down to the colleagues in WECON, and they answer you by writing it down, okay? So we can go further. So this is the drive. It has also, every drive has its own braking resistor, but we can hear on the main power socket, we can also put an external braking resistor. You will see this also in the next slides. This is an explanation of how do you make the right reference of each motor, or if you don't understand it, you can look at this table and see what the numbers mean in this reference of the servo drives. But this information is also available on the support page, so you can take a look there, and there is all this information available. Each motor or each set of servo motor and servo drive has 3 modes of control. They come from the factory programmed for the first option, that is position control. They can also make speed control and torque control for unwinding or rewinding systems. And according to our experience, if you choose the mode that you need, the control mode that you need, there is only few parameters that you have to touch to adjust the equipment. So if you want to, for example, speed control, you activate the speed control mode, and you can start almost running right away, because the parameters will adjust for this mode, and there is almost nothing that you have to change. Then we have also internal speed modes. On internal speed mode, you can use digital inputs to make this inputs correspond to the speed that you desire. If you activate one input or 2 inputs, the drive will run at the velocity that you program on this internal speed mode. It supports maximum 8 speeds setup, and you can use it by the digital inputs, okay? Internal position mode is the same as the velocity, the speed mode that we saw here, speed mode. The position mode is the same. If you need to a system that is a standalone system, you can program up to 16 positions on the memory of the drive itself, and then you activate the inputs that you have to program on the software of the drive. And when you activate the corresponding input to the position that you need, then the drive will drive to this position and stay there and waiting for the next step. So for a manipulator, for example, that uses I don't know, maybe 5, 6, or 10 positions, this can be a solution, a standalone solution to do. It is very, very simple and easy to do. About the resistor, the braking resistor that we have talked before, every drive has its built-in braking resistor. But in sometimes, if you have a fast deceleration, or if you have a high inertia of the loads, it may be possible to add a stronger, most powerful resistor to the drive, and this you can choose on the software. But before we speak about the software, I can show you this are the things that can demand or force you to choose a different resistor for the braking. It depends, for example, of the motor that you select, depends on the power supply that you have, depends on the mechanical operation, the load in inertia ratio, the maximum speed, and acceleration and deceleration also. These are the 4 factors that can force you to use an external braking resistor. But if we go to the mechanical point, if you put a gearbox. Normally on servos we use the planetary gearboxes, and you know, you reduce the velocity, but you multiply the torque of the motor, and then the behavior of the motor will be much smoother and preciser, and sometimes you don't need even the braking resistor. This is the application that you can download from the support page. This software is very simple, and it has on the bottom the compute button that you can put all the parameters you know, and it will calculate the resistor that you need. If you put the right motor and the right servo drive, depending on what you are doing, it can say use built-in brake resistor. But if you need an external braking resistor, it will put here the value about what you need. Then you have to introduce this also in the servo drive, so he knows that he's using with an external resisting braking resistor. I mean, those are the servo drives. Servo drives are known to have an integrated body design. They are very small, and they have better cooling systems, better protections. They can work from -10 up to 40 degrees, and supports 90 degrees without damaging nothing on the motor. So we have some applications on clients that they can touch the motor because it is very, very high, the temperature, but the motor keeps running without any problem. So those motors are very, very strong and powerful, and they can hold for a lot of temperature without being damaged. Those are the specifications that we have. We have the WD and WE series. You can see this also on the manual, on the support page. You have to pay attention also for the power, and the WE have 4 poles, 4 magnetic poles, and the WD have 5 poles, magnetic poles. Those here are the flange sizes. For example, 40 millimeters is for example, 100 watts. 60 millimeters goes up to 400 watts. 80 millimeters is for 0.75 kilowatt, and so on. It goes up to 180, but mostly they stay here on 130 square millimeters. We have motors that the minimum speed is 1000. Well, minimum speed. I prefer to say the maximum speed of the motor because minimum speed is 0. Okay, you can have a motor with 0 RPM and the maximum load, so they don't move. And the maximum speed, depending on the motor, can go up to 1500, and in some cases 4000 RPM. And again, the encoders can be absolute encoders or incremental. The most used are absolute, and we have the resolution of 17 bits or 23 bits. And also the power supply. The power supply, if you choose 300 volts, 3-phase servo drive, then you have to choose also the motor for this tension, okay, for 380 volts. Those are the aspects of the drives. You can see on the first one, the 60 by 60, they can be also prepared with brake units. Okay, on demand, WECON can supply you servo motors with mechanical brake. Okay, and here's how you complete the reference, the right reference of the servo motors. SC Tools is an application that you can download from this link. Remember it or write it down, or look for it on the support page. This application helps you to calculate and select the right servo equipment according to the torque, the speed, and the power you need. It will help you to calculate the right application, okay, or the right equipment for your application. WECON SC tool. This WECON SC tool is a software tool for WECON servo drive to commissioning and adjusting the servo drive parameter. It provides including a simulator, and you can adjust the settings of the parameters. You can export or import parameters. You can monitor and debugging the application, and you can make also a diagnostic of fault and error codes on your application. The interface from the SC tool to the drive in some applications is directly. You use a USB Type-C cable, especially for the VD2L, the VD3E, and the new one, the VD5L. It supports the Type-C USB cable, so you can do it directly. For the ones that don't have, you have on the top of the servo drive those connectors or J45 connectors. So you have to put in between the servo drive and the PC, you have to put there a media converter. Normally it is a USB to RS485 or 422 to connect to the drive. This is the aspect of the SC tool. It is also a very simple program. It's not heavy, and it's very useful to help us to program and copy the parameters and download to another drive without making a lot of efforts. It's as I told you before, if you choose the proper operation method, sometimes you don't need to use it. It is so fast and so easy that you can, by the silicon touch buttons on the front, you can choose one or two parameters to adjust, to adapt to your application, and that's it. Sometimes you don't need these applications, okay? This setting SC tool. To monitor, you can connect it and see what happens on the visualization parameters to monitor the torque, the power absorption, the heat of the internal equipment, and velocity, whatever. Everything you can see on this monitor SC tool application. For auto tuning, for those that have very complicated applications, this auto tuning can help. After you activate it, it makes some adjustments and automatically, so the most parameters are tuned for the load you are using with the servo drive. It is not perfect, but the most of the work will be done very good. And then maybe you have to touch a little bit some parameters, or maybe not. Sometimes it works very fast at the first time. But if you don't like the results, you can repeat this auto tuning as many times as you want to achieve the best setup. On debugging, you have here a waveform generator. It's like an oscilloscope that you can put whatever you want from the parameters on this scope, and you can get an image of the response of the motor according to the load that you have. So you can visualize the real response to what is happening. So you can decide very easier and faster what to do. Okay. You can go up to 4 channels waveform. Maybe the current, the power, the velocity, whatever. Diagnostic. If something happens, some error occurs, you can see them here. And of course, making the reset online of the drive and doing the repairings that you have to or you should have, so that the drive can work without any kind of troubles. So now we will talk a little bit about servo system applications. Servos, as I told you before, can be applied in whatever you like. Some machines that used to have the ordinary AC motors, you can change them by a servo motor and a servo drive. We have here, for example, a Delta robot. This is the robot. This is actually application that was made at WECON. This was programmed by a CodeSys PLC, the LX6C, and 3 servo motors and servo drives controlled by EtherCAT. This is a machine to sort LEDs. It is a very fast machine. The positions, let me see if you can run the video. I think this is a small video. Yeah. You can see the fast that you go. This is a slow motion movement, so you can see what he's doing. Okay, this is very slow, but at the beginning you could see that it is very, very fast. Okay. This is the actual velocity of the machine. Winding machines. The key points, the VFD is used at the front end for unwinding. Servo is used for winding, high efficiency and cost saves. So if you use an ordinary VFD for a normal motor, and you use a servo motor for unwinding or winding, you can control the torque that is applied to the weft or to the plastic or to the sheet, whatever you are rewinding. So you can use the continuous torque to the whole process from the beginning to the end. The tension remains constant in unwinding or rewinding. The rod feedback, the servo internal automatically identifies the size of roll and automatically configure. It means if you have a roll that is on the starting, it must run fast, and you can be sure that you will have the torque that you want. But as soon as the roll starts to growing, the velocity will have to be decreased, because the peripheric velocity must be the same, but the torque must be also constant. So this is only achievable with a servo motor and a servo drive. This is a control cabinet with 2, 4, 6, 8, 10 servo motors. You can see the servo drives here, and they can all make different. In this case, they are not connected by Ethercat, so they are connected by the normal I/O interface. But for example, this kind of rewinding machines, you can control very precise the winding of the machine of the product. I mean, side drilling machine. This machine can drill whatever you put there with the precision of 0.1 micron. It's not 0.1 millimeter, it's 0.1 thousandths of millimeter. It's very precise. This can be done by the VD2F, and they put here the load of the inertia was set up by 450% and the rigidity to 14. The rigidity, you can play a little bit with this, because if you increase it too much, then the motor will be very noisy, very stiff, very hard, but noisy. Okay, so don't push it. This is a stone multi-axis integrated machine. This is also we have some clients here in Portugal that uses this stone cutting machines mostly in 3 axis, but this machine has 4 axis. The blade can turn around, and you can actually interpolate the XY axis and cut rounded shapes with this equipment. So you have only here on the image, on the left image, you have a frequency converter for the disc, for the cutting blade, and then we have 4 servo drives for the X, Y, and Z axis, and then for the A axis, normally they call it A, the turning the disc. This is also a very normal application and use it a lot. This machine is it's not axis, it's axis, okay? 4-axis door processing CNC. This is a machine where you put the door on top of it, and after you adjust the dimensions and so on, you can drill the bores or bore for the winches and for the door lock and for the handle. This is a machine that makes in maybe 1 minute or even less the man work of 20 minutes to open this by hand. So this machine is very fast, and it is also very precise. Okay. On the top here, you can see on the right hand on the top, this is the newest version of occulted winches. You can't see the winches from the outside. This is also made. It makes the central hole, and then the wider and not so deeper hole to connect the winch, and it stays there perfect. So this was made with some simple servos. You can see here the application. We used the information from the support page from the internet, from WECON, and we are using only sign and direction pulses. In this case, in quadrature. It means it works with A and B, not sign and direction, because the controlling mode, it's not from WECON, it was from the client, and he wanted to use it, so he used this controlling unit, but the principle is the same. Okay. This is the sample of the connections of the power. So we have supplied there 230 volts that is used on Europe to power up the drives. Then we put the connections for the references. On the top, you can see the power supply for this IOs with 24 volts. On the buttons, you can see only two IOs. The first one is to put the servo on. It is like the enable. And the left one is an alarm. If something happens on the equipment, it turns on this output and connects a small relay, because this has a PNP output, and the client was using an NPN output, and then we have also to collect all the four relays to make a mesh of interface as a security net. So if some of them opens this net, the machine will stop. It's the security of the system. And here is the output of the actually the equipment of the client calls Inno PLC. This product has 3 digital outputs for 2 different AC motors, a VFD, 2 VFDs. It's like the spindle of the machine, and they are controlled in binary with 3 digital outputs for I think 4 or 5 different velocities, okay, in binary. And then they have here pulse and pulse plus, pulse minus, and command or direction plus and direction minus. But as I told you before, this is controlled by quadrature. It means this channel is A and the second is B. So what comes first tells the drive in what direction it has to drive. If the A comes first, it runs to one direction. If the B comes first, the drive will move the motor in the other opposite direction. So you can see the control cabinet of this machine. There are the 4 axes already connected to the controller. The controller is in another part, so it goes out to another position to make the control. This is the outputs for the motors and all the interconnection. And on the right side, you can see there the 2 VFD drives that we have spoken about for the spindles. This is another application. This is a very recent one. This is the roll to sheet cutter. What does this machine do? This client used to sell a very small machine to cut rolls of plastic, rolls of bubble plastic, rolls of Teflon, rolls of whatever. Some clients use to buy only sheets, not the entire roll. And this machine is to cut on the precise dimension of the sheets. It is a very simple machine, but he used to use a DC motor with a DC controller, a logo from Siemens, and several of buttons to push forward, reverse, to adjust the measurements, to adjust the velocity. It was a real nightmare. It was a mess. But the machine was simple, and the clients liked it. So now we help them to develop a most advanced one with a touch display, with a PLC, and the machine is now very, very faster and much more preciser. because we have put there a servo motor with a gearbox, a planetary gearbox. On the right side, you can see that the unwinding system can be simple or with a special unit to have a better control, or maybe unwinding two rolls of different products. There's also a photocell that can stop the machine if the product ends, and longitudinal cutters to adjust the width of the machine, of the products that you have to cut. This is the aspect of the machine. So you can, as I told you before, you can cut on this machine bubble foam, transfer sheets, paper, plastics, vinyl, and also Teflon.
这个也要减速机的啊。
So this is the interior of the first machine. So it doesn't look pretty, especially here on the PLC. But this was the prototype. Now it is much better organized. On the left side, you can see the servo motor and the gearbox that is connected then via belt to the pushing rolls. On the upper pictures, you can see the left one, there is a servo drive and the PLC with the power supply. And on the left, on the right side, on the bottom, on the right side, you can see the contact for the emergency stop, the power switch on and off. And on the bottom, you can see also their interface to connect the HMI to the grid. So this is a IGO HMI that you can connect to the net of the company and access directly to it and do what you normally use by hand. You can, for example, you can remotely fill in the receipts of the machine. So when the worker comes, he only starts the production. He doesn't have to introduce anything on the machine. This machine has an interface that was already developed for 6 languages. This client sells this machine everywhere in the world, especially on the United States. And the company called Stagi Servi. If you want to see more about this machine, you can write down this link. There is a video of the machine. It is a long video that explains you everything, how the machine works, the setup of the machine, the receipt, everything. It will be explained also in English. If you then after this, if you have any doubts, you can call me or call the colleagues of WECON, and we will be very glad to help you somehow. And this is the WECON technical support. This site is where you can find everything that we have talking about servo drives, and also about PLCs, HMIs, the VBox also. You can find all the information on this site, okay? Remember it, write it down, copy it, or do whatever you want, but use it, okay? I can assure you that the most of the questions that you have will be dissipated on this site, okay? So from my side, I thank you very much for your patience to hear me. Sorry for my not so good English, but I hope that you understood. We are here to help. If you need something, don't hesitate to contact us. Peter, it's your time now, or maybe
Yes.
Mona.
Yes.
Yeah. Okay. Okay, thanks for David's introduction today. David has been dropping servernology booms like a professor. Thanks for David again. And we haven't forgot our promise. As a big thank you for being here today, we are about to give away some super cool gifts for a lucky winner. So maybe we can take a look of the gifts first. Thank you for your. Thanks. A minute, please. Let me share my screen. Okay, we prepare a cool and functional gift for you. Sorry, a minute, please.
David, maybe you have to close your PowerPoint in your side and your share.
Yes,
Yes.
it's closed already. Please try again.
Okay, thank you.
Okay, so let's say a small function lighting, and we will use the wheel to draw the lucky winner of this webinar today. So let's start the lucky draw time now. A minute, please. Okay, so your all guys' names are in the view here. So let's draw the lucky winner today. Let's go. So who will be there? Okay, congratulations to Chief. Sorry, my pronunciation is poor, but my heart is genuine to congratulate you. So we will send a small gift to you with your order. And thanks for your join today. And thanks for David's introduction. See you next time. If you have any questions, or if you want to know more details, or you want to get the record or the presentation, so please feel free to contact us. Thanks for your joining today. Bye bye. See you next time.
If you have any questions, please don't hesitate. Contact us. We will be very glad to help you. And if you don't find on the internet the answer to your questions, send us an email or give us a chat, whatever. We will be very glad to help you. Okay?
Yes.
It's okay. You guys, if you have any questions, you can talk to us now. No problems. We arrange the time to answer. If you think it is far, it is very helpful. Okay.
Thank you, Ben.
I will keep.
Thank you.
I think Mona, we can keep around maybe 3 or 5 minutes here if anyone have any questions.
Okay.
Yes.
Yeah.
We can. We were waiting. Yeah. If you don't have questions, see you next time.
Hello,
Hi.
this is Ismail from Iran, Faransis. How are you?
I'm good. Thank you. Welcome.
Thank you for the nice presentation. I really like it because we have a lot of experience for doing the business on servo drives and servo motor. My question is, do you have any plan for bigger size servos, for example, 50 kilowatt or 20 kilowatt like this?
Peter, please. My earphone is a little
Okay.
cool.
Okay. Hello, it's me. Thanks for your question. Yes. If I understand well, you want more bigger server drive, right? Or server drive, more bigger one. As for now, we are planning to do someone bigger than 7.5, but it is not enough like 20 kilowatts, like 50 kilowatts. But I think if sales and your business is running well in the future, we were considering. And our sales guys will update news to you. But now, sorry, it's a pity we don't have. Yes,
Okay, thank you.
yes, okay. Yeah, I think you can list what you want to your sales guys, because WECON always developing, always listening the requirement from market. If some guys really have good opportunity, we will feedback to PM and R&D they were considering. So it's very important, and we're happy to hear from you. Yeah,
Thank you very much. Thank you.
thank you. Any other guys have any question? If you don't have question, we will stop here today. And it is very honored to have the time to invite my friend David Correia from Portugal to introduce the server. And I hope we will see you next time for more knowledge and information from WECON. Today we stop here. Have a good day, guys. Bye bye.
Bye bye.
Bye bye.
So, okay.